to subtract radicals with different radicands, they both need to be simplified first. We are looking at the square root of 48 and the square root of 75. So if you could find some common factor in them, that would be great. And then that could help lead you there. I know that 48 and 75 are both divisible by 3. 48 divided by 3 gives me 16, which is a perfect square. 75 divided by 3 gives me 25, which is a perfect square. So that's a good way to go. So I'm going to re-express this as the square root of 10 times, and instead of the square root of 48, I'm going to put the square root of 16 times 3. And then here I'm going to have minus 3 times, and instead of the square root of 75, I'm going to have the square root of 25 times 3. Now I can try to simplify each of these. So negative 10, the square root of 16 is 4, and the square root of 3 will stay. So this is really negative 40 times the square root of 3. Minus 3 times the square root of 25 is 5 times the square root of 3. So that would be minus 15 radical 3. So negative 40 radical 3 minus 15 radical 3 would be negative 55 radical 3. So as strange as that looks, the idea here was I found a common factor, or I basically found a perfect square factor of each of these by finding the common factor that would be left after that perfect square was extracted or removed. So I looked at 48 and 75, saw that they each had a 3 in them, and that told me that a square root of 3 would be left over after the perfect squares came out. Now looking at this one, I'm going to subtract these two that have different radicands, but again, I'm going to look for a common factor that would remain under there, and that would be the x. So there's an x under there, and we need to look for something else. Well, I know that 8 is 4, which is a perfect square, times 2, and 18 is 9, which is a perfect square, times 2. So I'm basically going to have a radical 2x left over in there. So now I'm going to simplify this one. I have negative 5, and instead of the square root of 8x, I'm going to do the square root of 4 times 2x minus 6, and instead of the square root of 18x, I'm going to rewrite that as the square root of 9 times 2x. Negative 5, and then the square root of 4 is just 2, and the square root of 2x can't be simplified, so this is really negative 10 times the square root of 2x. Minus 6 comes down, the square root of 9 is really 3. The square root of 2x is the square root of 2x, so negative 6 times 3 would be negative 18 times the square root of 2x. And now I have negative 10 times the square root of 2x minus 18 times the square root of 2x would be negative 28 times the square root of 2x. So with each of these, the idea is to look for some common factor of the two radicands that will remain at the end. Here I saw that each of these were divisible by 3, leaving perfect squares of 16 and 25. Here I saw that each of these were divisible by 2, leaving perfect squares of 4 and 9. The x was also remaining. So with each of these, you should be able to factor or simplify each of the radicands, find a common factor, and then express by adding like radicals.